Hello there again. This is Unit 2. Happens to coincide again with Chapter 2 in your text, where we're going to talk about tissue types and functions. So let's get to our content here. Again, the introductory slide. This will be repeated in your Canvas module for this particular section, so we won't go over it. Get on to the next content area. So first, let's talk about epithelial tissues. And you all know these mostly as skin cells. But we're going to hit on the properties, locations, functions, and varieties of epithelial tissue because it serves a whole host of different functions within the body. Of course, it's typically a huge collection of cells packed very, very tightly together. And we know this clearly, typically, when you talk about skin cells, because if you scratch your skin or have a cut, you can kind of see the layers of skin as they peel open, especially during healing time. But also epithelials line different tubes in the body. So if you think about arterial and venous tissue, epithelials actually line those canals within the body. Makes up hoof tissue, makes up nail tissue, things of that nature. And of course, one of its major functions, for example, is to protect the body from trauma and fight off bacterial invasion. Otherwise, it would be very, very easy for bacteria to get penetrated within the body. Furthermore, as we talk about their functions, they of course have a variety of different secretions, and these are oftentimes based upon the specialized type of epithelial cell that you might be referring to. There are epithelial tear cells that produce tears, saliva, urine, sweat, obviously, and then there are milk epithelial cells within the mammary gland. The cutaway here on the right side image is of just a skin cell that is showing a sweat pore, hair shaft growing out of it, and then all of the specialized cellular tissue that's underneath it, the many layers of epidermis and epithelial cells that are packed tight together there, and then all the way down to the fatty tissue, the arterial and venous system that then feeds that cellular tissue. Moving on here, we talk about different classifications. They're often classified by the number of different layers and the shape of the cells. You see in the image on the left, different shapes of epithelials that you might find, and they are used together to describe the type of epithelium. So in the image on the right, you obviously see a cross section of a cow hoof. The coffin bone is typically a triangular bone, and I'll try and outline it here with my mouse. That sits kind of right here in the bottom. It's pointy towards the toe, and it is obviously made of bone. The rest of this tissue around here is all epithelium that's formed of epithelial cells. Of course, we have to then transition and talk about connective tissue and the different functions and locations that you might find connective tissue in the body. First, obviously, is tendon. Tendon connects muscle to bone, and that's kind of how you make the limbs move. So it's, of course, very, very important for that to function and be made properly. You can see the cutaway image on the right here of a chicken. You can see the tendon and the gastromeniscus muscle that it connects it to, and that tendon will help make this muscle move as it connects it to the bone, and the bone within that tissue move appropriately. Then you have, of course, ligaments that connect bone to bone so that we can bind those structures together and make them move in concert with one another. And it's important when we talk about that bone and cartilage relationship, and specifically, we can drill down and talk about hyaline cartilage, which is the cushion function within bones and joints. And of course, you can experience pain in joints if some of that cartilage gets damaged or even deteriorates, where then you get bone grinding on bone, which is, of course, extremely painful. Of course, then there's also elastic type cartilage, which helps form your earlobe or your epiglottis within your voice box and throat. And then, of course, there is bone tissue. Next, we also have to talk about adipose tissue. Adipose tissue is the fat storehouse of the body. And while many of us kind of scoff at the need for it, and some of us have more of it than you would wish, adipose tissue, the fat storehouse, is exceedingly important. Your body has it for a reason. Of course, there are times that you will go through where you need energy reserves within your body, and that energy currency is stored within adipose tissue as fat. And so the body has the ability to mobilize that body fat in order to keep body function maintaining should you encounter a time of illness or malnutrition in which you can draw upon that adipose tissue. Blood is actually classified as connective tissue that is in a liquid matrix. Of course, it is the vehicle for transporting a lot of things throughout the body and necessary for, of course, healthy body function. Let's move on and talk about muscle tissue next. And of course, first we'll talk about smooth muscle, which is the involuntary type of muscle. Really functions without any conscious thought whatsoever and is controlled by the autonomic nervous system within the brain. So think specifically about your lung tissue, your stomach tissue, that you don't control anything about what it does, where it goes, how often it works. It just works because the body tells it to work. Next, we'll hit on skeletal muscle. Skeletal muscle is all striated, voluntary muscle, so it moves based upon what the brain and the body tells it to do and what direction it's supposed to go. And again, it's extremely complicated. We're not going to get in real depth in terms of muscular tissue and why it works the way it works in a real deep sense. We just want to understand the muscular tissue, how it's formed, how it grows, and how it's impacted by different health challenges. Cardiac muscle is classified all its own because it is very highly specialized, and of course, again, another involuntary muscle, but it is striated in appearance. So that's why it gets its own classification. It's striated like skeletal muscle, but involuntary, like you saw with smooth muscle. So it's somewhat different. Need to point out here the connection between calcium and muscle. There's a couple different diseases that I pointed out down here at the bottom with regard to porcine stress syndrome. So for example, if you're onloading or offloading hogs onto a trailer heading for the pack-in plant, how you treat those hogs affects the muscle tissue, primarily driven by hormone excretions, and that can actually seize up the meat or make it pale and soft and therefore tasteless. So it's important that animals are treated in a very careful manner whenever moving them. Hypoglycemia or hypocalcemia, and milk fever in cattle is where we have a bone as a storehouse, a huge storehouse actually, for calcium. And there are times, of course, when the animal transitions from the dry period through calving, foaling, or farrowing into having to produce milk at high quantities, where the need for calcium goes from quite low to very high quickly. The storehouse is calcium. So if they cannot eat enough calcium to meet their dietary needs for milk production, they draw on that from the bone tissue, that extra calcium that's needed. Nervous tissue then, of course, we'll dive in and talk later on about the nervous system in more detail, but just some general overview here on neurons. First, we have sensory neurons, and they are the ones that respond to stimuli from your environment. The response to light, the response to heat, the response to sound. We have interneurons, which are stimulated by sensory things, like in the central nervous system. So like your ability to taste and smell. And then, of course, we have motor neurons, and those actually originate in the central nervous system and stimulate the muscle or gland into action of some kind. Down here at the bottom left-hand picture, you see this purple glob, it looks like, with tentacles coming out of it. That's actually a nerve impulse that's moving through the nervous system. On the bottom right-hand picture, you see then the nucleus of that nerve and how it moves through the dendrites up and down the nervous system to cause certain things to happen. So whenever we need to respond, motor neurons will actually be stimulated for us to get up and move or move away from a heat source or something of that nature. Some clinical practice things here. Again, we mentioned that you would see these on example of where you might find different diseases and so forth impacted. We're going to talk about foot and mouth disease much later on in the semester. But this upper right-hand picture is a photo of an animal, of a cow that has foot and mouth disease and a huge blister that has opened up in their mouth. It's exceedingly painful. Of course, we have traumatic injury. We have Horner syndrome, and you can kind of think of that. This is a picture of a dog that has Horner syndrome. It's actually a little bit of like a lazy eye type of look. The bottom left-hand photo then is a picture of foot rot, where we have epithelial tissue that's been affected by a pathogen. It's swollen. It will slough off. It'll be very, very painful and red and hot to the touch, and of course, very traumatic for the animal. So as we wrap up here this Unit 2 lecture, we got to talk about some of the summary things. And so basically, just understand that epithelial tissue lines nearly all of the body surface, both inside and out in some form or fashion. And then connective tissue varies, and it's also highly specialized in the different things that they do. As we deal in vet science and animal health with different injuries or disease, we need to know which one of these that we are affecting with our medical treatments and our diagnostics, so that we are doing things both appropriately. Thanks for tuning into this section. I look forward to interacting with you throughout the assessments in Canvas.